but I had it working the other time. So really, I've been trying to read documentation, and I haven't had time yet to implement OpenAL on Windows or anything of the sort. There's some other libraries. Oh, I think I lost the URL for the Reddit ones. Or maybe I saved it somewhere. Um, I think I did, but it's probably bookmarked. But yeah, so SL engine create function. The use cases. So I like use case 7 since it has a way of making me understand why all this is important without having to just bore me to death. Even though this bores me to death, especially this API. I don't know why I find the sound API is just stupid. Maybe I understand them in an electronics point of view, but programming wise, I just like get bored. The graphics a little more fun because it's graphics, right? And sound is just kind of, oh yeah, we hear stuff, but it's actually the same thing in terms of the quality. Like, it is fun. It's just I haven't experienced the drug of it. Um, so you got your MIDI player, got a bunch of sources, and the sources can have all these properties: time, cue, mute, solo, message, tempo, meta extract, transverse style, seek, which basically means rewind, volume, well, how loud it is, and play. Polyphony. That means, like, I think the amount of melodies it gets or something. Prefetch status. It fill level accuracy 10. I don't know what that does, but I kind of get an idea. Something to do with buffering or something, or for filling. Okay, or an audio player, a buffer source, and a Java tone sequence. Play volume seek, still sound effect. So the other one is a player with a buffer. Wait a minute. I don't think this was the case one. This wasn't the one I wanted. Yeah, it is the game profile case. 2x this. How about the 8? Was the 8 like the standard game thing? There's like 3 sounds being mixed. There's 3x of this, a buffer source, going into an audio player. So there's like 3 sounds playing, right? And then there's 1x buffer source. There's one primary, like always, for the ambient sound effects. For the 3D non-Drupal sound effects, it's not abusing this, or or playback for Drupal and pitch rate affected sound 3D sound effects. There's 2x of these, so it's mixing 6. So there's 6 being in case 8. And I'm guessing you take one of the 6 and just play the music on that for case 8. I'm gonna go back and read a little more, but first it's like, I think there's more fun things to do in here than this, besides reading the diagrams. Okay, buffer source 1x, file source, MIDI buffer queue. So there's things are different. The file source and buffer queue and MIDI buffer queue. And there could be a file source bank file and a file source XML file. Ooh, fancy. Okay, this use case 6 I think is a monster. So that's the bottom of the use case. Then there's 3x for a buffer source, a buffer queue source. basically you're not reading from a file, you dump a file into a buffer, and there's another buffer source for playback of ambient sound effects. So like ambient sound effects, I find that what if there was two at least ambient sound effects, and you could play some of the ambient sound effects within the primary buffer, which we'll call the one with the most X's, like 3x. It's usually the one in the middle. Then there, for playback of Drupler and rate pitch affected 3D sound effects, there's one of these. Use case 6. Use case 5. Yeah, so use case 5, the first thing is a music file from a file source. Then there's 2x for 3D affected sounds with Drupler pitch accelerated. 1x for playback of ambient sound effects. And 1x for a MIDI player in 3D. Interesting. So, before we go to use case 4, let's go back to our Android page and see how this has to affect Android. Because there's like, I find that there's not that much information on OpenSLES. And the one thing I started out noticing is that OpenSLES is 1.01 standard. Wait, what does that say? I have to like zoom in. My eyes are already tired today. It does say, damn it, it left the place it was at. I like what it was saying. Something about the standard. Oh, now I'm reading through everything. I'm just trying to find a position. Something about something. Oh, there's programming notes. Besides the specification. Open a new window. I think I need to restart soon. I got an emulator running. So there's these programming notes. The programming notes say that it's deprecated. Yeah, so SL object ITF is an object handle. It uses these objects that must be allocated in order to use OpenSLES. That's how it handles objects, and it returns, and they're realized unless you run out of memory. So there's a page that says that. And there's this thing called a dynamic interface management, which add interface does not work. Instead, specify the interface and array path to create, as shown in example, environmental review. So, and the Android high performance API are based on Chronos Group OpenSLES 1.01. Chronos has revised standard 1.1 of the standard, but revised increased new features, clarifications, typographical errors, and some incompatibilities. Most of the expected incompatibilities are relative minor. There's OpenGLS and not supported by Android. So basically we're stuck with 1.01 standard. And important thing I wanted to point out was it said it on this page, I believe, but it was that I forgot even what I was going to say. It was the allocation of the thing. It said it like right in the beginning. Oh, here it is. The global entry points. So it does this thing, kind of like getting the context for OpenGL. Yes. OpenSLES for Android supports all the global entry points in the Android specific. These entry points include SL create engine. So this is like the first thing you do. You create this engine thing. Then there's this create engine. Then SL num supported engine interfaces. So your your sound card or your SoC system on a chip, it's only going to support so many interfaces. You can't just like mix as many sounds as you want because you want to, unless you do it through some sort of software where you would actually need to write your own mixer library, which means like coding sound on top of sound. Not something that they give you, but you could also do it yourself, kind of like in graphics, where you can generate a bitmap and then pump it into the texture sampler. So you're doing like these like software rendered graphics on the CPU and then send it to the GPU. Like all these little tricks you could still do on there, but you still have to know the interface you're going to pass it through, and that interface has limitations, and one of the limitations is how many interface buffers you're going to have. And they're called like different things. So buffer queue, there's a buffer queue data locator. There's a dynamic interface management. Effect send, engine, environment, reverb, equalizer, IO device data locator, meter, extraction, mute, solo, object. We talked about that object thing. So the object is yes for audio player, yes for audio recorder, yes for engine, and yes for output mix. So whatever this object thing is, it's everything. So it kind of makes this table. This table is like really confusing to look at first. It's like, well, why would they have this table? Like, why is bass boost in audio player, but it's not in like audio recorder or engine, but it's in also output mix? So I guess it can be attached to both those things. What does this say? The following table shows objects and interfaces that Android indicating implementation of OpenSLES supports. If yes appears in the cell, then the feature is available in the implementation. The Android indicates support for objects and interfaces. So the bass boost is yes audio player, no audio recorder, no engine, output mix, yes. The buffer queue, yes, and no an audio recorder, no an engine, and no an output mix. Buffer queue data locator is yes with the word source in for audio player, no for audio recorder, no for engine, and no for output mix. And then dynamic interface management is yes for everything. Effect send is yes for audio player, no for all the others. Engine is no for audio player, no for audio recorder, yes for engine, and no for output mix. So that doesn't make any sense. So engine is yes for engine. So there's this thing where it does engine create engine. So the word engine is like doubled up inceptionally or something. We go look at the documentation again. We also look through the header files and stuff. Really hard to find the word engine up in the index. Yeah, the engine object. Let's read about the engine object. This object type is the entry point of the API. An implementation shall enable creation at least one such object. By attempting to create more instances, either by a single application or by several different applications, you may fail. So you're not supposed to do that. You're supposed to just make one of these. The engine object supports the creation of the API's objects via its SL engine, its F interface, and querying the implementation capabilities of its SL engine capabilities, its F interface. See Appendix B and Appendix C for examples using this object. Alright, so in creation, an engine object is created by using the global function SL_create engine. Well, maybe I was wrong about the double engine part. Alright, that's how it starts looking out when you create it on the I was going to say client side, or the client side of the application, yeah, because that's the API side, which is the server side. And I'm not talking about networking, I'm talking about API wise. But more, I should have said, instead of client side and server side, more the application front end side versus the back end side of the API. Which also doesn't make any good familiarity with web development. So, trying to use the right semantic words in order to describe it. Yeah, so there's these other ones. There's thread sync, there's SL engine, iterator, dynamic interface management, SL object it, mandated interfaces, so these are mandated, which means they're required. This interface is exposed with basic object functionality. This interface is an implicit interface of this object. This interface is used for adding dynamic interface section to the object. This interface is an implicit interface to the object. This interface exposes methods for the creation of all API objects. This interface is an implicit interface on this object. SL engine capabilities, ITF. This interface enables querying card implementation capabilities. This interface is an implicit interface on this object. SL thread sync, ATF. This interface enables synchronization of API client application context. This interface is an implicit interface on this object. OpenSL 1.101 specification. SL audio I/O device capabilities. This interface exposes methods for querying available audio device capabilities. This interface is an implicit interface on this object. So, without having to do a lot and getting it all to work, this SL audio I/O device capabilities, ITF function, would be fun to call and just do a bunch of prints. And then the same thing with the SL audio decoder capabilities and SL audio encoder capabilities. And this interface exposes the 3D commit control for all 3D parameters within an engine. So I guess this 3D interface, this SL 3D commit, will tell you kind of how much 3D gaming stuff you could implement. This interface is mandated only in game profile. In the game profile. Applicable optional interfaces. So I guess you can't just set up any kind of random game profile that you want to set up. Maybe you can. LED array I/O device. The LED array I/O device object encapsulates, controls, and sets of LEDs. It is functionality covers setting LED color, activating and deactivating LEDs. This object is a standardized extension and consequently optional for all profiles. Alright, so let's go to Appendix B, I think it said. Where's Appendix B? I believe it's on page 500 or something. Oh good, there's a bunch of prototype code or something. We're still on page 414. For some reason it's empty. I believe I downloaded this file. so I wouldn't have this issue. Yeah, so now I don't have this issue with being blank. Alright, so we're on page 501 and we see some code. Test advanced 3D code. Create a 3D source and spin it around the listener. Ooh, this is how we do everything. Gunshot, scream, footstep, and torch. So there's these 4 objects, right? And there's an engine and a commit 3D thing, and a location and a source, a driplet effect, a listener, an output mix, and there's a boolean, the required max number of interfaces, and interface ID. So that's probably the amount of sounds we could play. Get the SL interface, which is implicit. Then it gets an interface. Max number of interfaces, it like puts them into arrays. Then those interfaces, it gets the interface and then sets deferred, whatever that does. I guess it like initializes them basically. Create an output mix object to be used by the player. No interface is required. So there's it just created an output mix object, realizing the output mix object in synchronous mode. Create 3D listener. So I guess you could realize an output object in asynchronous mode then. Realizing listener object in synchronous mode. After creating a listener, create 4 players. Create 4 players with differing priorities. Higher priorities are used for sound effects that might be heard by game player, whereas lower priorities are assigned to sound effects that make the game sound better but are not required to appreciate the game. Ooh. So create 3D sound. Alright, so here's the kicker. They're passing in wave files into creates 3D sound function. And the parameters are the engine, the output mixer, the handle for the interface, which is gunshot or ampersand gunshot, the file name gunshot.wave, and then the priority to high. The second call is also to create 3D source interface to engine, output mix, scream, ampersand, scream.wave, and normal priority. Then it's footstep with normal priority, then it is torch with low priority. Then we get the state. So they're trying to be really fancy here, doing all this. I don't even know how to get the first part started. Well, I do. I made it call a sound, but it works through a buffer. Now, why I really was stressing out about that whole wave part was because my sounds are an OGG format, and I'm trying to save a lot of space, and I want buffers because that way I can support OGG format. Okay, so here it says play state, get interface foot, play, get interface. Yeah, so footstep interface. So it's kind of doing it the way I was trying to set it up. Kind of. The second time with Mr. Gemini AI Bard, and it wouldn't return to me the buffer queue interface, I believe. It would just give me null, and my object would be screwed. My whole like the sound object, and the sound object would hold like all 4 of these interfaces. It would hold the object, it would hold the interface, it would hold the buffer queue, and it would hold the other object, whatever the thing is called. I forget what the other one's called, but I'll remember here. If I were to look at the code, I could say exactly what it was, but I'm sticking to looking at this document because I don't know if I'll get to do this today, but I'm just definitely just trying to look at the samples here, because these samples are really the key. They're at the end of the specification. You look at the specification, you die, your brain just rots by the time you hit page 200. And if you scroll all the way down, your brain still rots. Even if you see the source code, you're like, oh, this is death. Really, what you have to do is you have to start out kind of slow on this. I believe. Maybe some people are better at it than me at getting through this. So this looks like it was used on Windows for this code, because I see this file :// background music. I don't know why they set up a data source structure for the background music. Maybe it will work like this. Audio X-Wave. Maybe there's different container types to open different type of files. So here we create an audio player. So this is the confusing part, is they create these audio players, but it's like, do you create one audio player, two audio players? And the answer is it depends. And it gets really frustrating and confusing because you create them for different things. There's an audio player for the music, then there's an audio player for sound effects, and there's another audio player for sound effects. Ooh, why? Because different things, and one can support reverb or the other things and 3D, and then one can just be like plain or something. And we got all these other things about thread safety in here too, because you somehow want the audio engine to be on a different thread. Max number interface is 5. Alright, so this is some equalizer example. Yeah, I think we got equalizer, reverb. I don't know. I think one of those means echo too. So interfaces are things like volume and equalizer. Realizing the output mix object in synchronous mode. Alright, so I'm just keep reading the specification. So really the idea is to go to the back of the book of the specification, to the bottom pages, and just try these examples. Or just adapt one of them. What's a Vibra devices? Okay, I'll find out when I read this. Korea available for MIDI. No, MIDI is mandated only in phone and game profiles. So voice type MIDI. number of LED devices. Whatever an LED device is. Like, it doesn't tell you what the LED device is. Like, what does the LED stand for? Does it stand for light emitting diode? Like, that's what I know LED stands for usually. Alright, so it ends on 255. Oh, no. 523. Use case sample code introduction. This appendix sample code introduces how objects could be used together to support one simple case for each profile. A description of each case is followed by an object relationship and sample code. The sample code shows how to use the API for purposes of illustration only. It is not intended to provide realistic application code. Specifically, the sample code uses get chart for purpose of illustration and only indicates limited error handling for the sake of clarity. Music profile. 2C music profile. This example shows the API is using in the following case. Play music from file, adding and removing reverb, enabling disabling stereo positioning when requested by user. The application also receives music playback progress indications via callbacks so that progress bar can be displayed from user. The research reverb is added dynamically to illustrate of the dynamic interface management functionality. Alright, so cell engine, audio player, audio mix, creates, object, engine. Okay, this should be an interesting sample because it looks kind of simple so far. So like it, there's just an engine, an audio player, data source, an output device, a data sync to an output mix. The data source of the URI is the only kind of real bummer. So it just plays the music file. Just a check for some key presses, disable some stuff like stereo or whether or not it's playing. Reverb. And there's the main function, and it plays all of it. Yay. And I'm like falling asleep. But I think I got to the kind of the end of the book. Alright, phone profile. Got phone profile next. Alright, we got a little bit more here. We've got the audio player and the MIDI player. Then it goes to the output mix, hands-free output device, and handset output device. This one has more than one output devices. Interesting. 2 syncs. Max number of interfaces 3, max number of output devices 6. So it shows you how to do that. And there's no error checking. So it loads a music file. What else does it load? Allocate some devices, because they're the output devices. And then it dies. Game profile, more complicated. Audio SL engine, there's a 3D group, there's an audio player, there's another audio player, and there's a MIDI player. So this might be the easiest one. And there's a sample, nice. Car speed, sec. Speed of car in milliseconds squared. Speed of car in 50 kilometers per hour. Test game, so it is doing all this cool stuff. Start velocity, location, and it's using like 3D stuff. Vectors, and then it just reroutes it to the mixer. There's this reroute function, set environment, rebus, sets the interfaces. I should read through a lot of this, but I'm not. I'm getting like really tired. Create output mix object used by all players. So I'm guessing like the number of objects. How does this number of objects come out? Oh, it's the max output devices. So the output devices are different headsets to be available. So yeah, like there's some Android devices that have 2 headsets. So imagine you had like 6 plugs or something. Or you had a TV table and you had like 8 players playing, and you had a speaker per player. Or 2 speakers per player. Then It's the main function and runs through all that. Alright, object, appendix D, object interface mapping. Well, this looks like scientific or something. Well, this looks like a bigger table of the other table. Oh, great. And then there's more table. I wonder why the developers were playing Tetris. So they would make it so you would read the boring stuff last. I mean the cool stuff last. This interface is mandated for all players. Now they don't mean like the game players. They mean like the sound players. Oh, that's confusing to say. With Java tone sequences, JTS data sources. So who cares about Java? I think that means something else. What are Java tone sequences? I don't think it means the Java language. Let's ask Copilot. He's lagging anyway. He needs to get some work done today. At least one question. Except for Android emulator hypervisor driver question that I asked him like 3 times about already. Keep asking the same questions every day. Expecting it to fix my computer, but it can't. The answer was, don't get an ARM image. Oh yeah, I gotta go delete some images that are ARM. Just get an x64 image, just let it run slow. And it worked. My emulator now runs. I got a watch emulator and an Android emulator. And I can go get a TV emulator. And a car emulator. Just publish the app like that. Java tone sequences. What are... Oh, they're generated like an endless tunnel. Yeah, so they're just generated using math sine function. And you could just make a bunch of game sounds like this. Generate a 440 hertz tone for 1 second. This is the fastest, I mean the most compressed way. You could just make a little sound real quick. Nice. It gave me the template. Math pi times 2 and sine function. Yep, that sounds right about right, because when you draw the sine function, you graph it against 2 pi or whatever. That's where it repeats. And that's how you generate a signal in electronics or a sound. If you get something going up and down at a certain time rate, then you time the hertz, you could make a receiver or a transmitter or something. Alright, so I kinda understood a little more. I'm still very lost. I think I was less lost the first time I did this, and I just written the native audio example and I just copied it. But I'm sort of more familiar now with the advanced stuff. Except for I don't see how they're like importing WAV files. I see how they're doing it. There's a function that just eats WAV files that's built into the internal API, but then if you want G files, you have to do a little bit more footwork and import it into a buffer and have different buffer queues and manage those buffer queues somehow, and Maybe have a 3D object thing and link it all together. Alright, do this some more later.